Good morning, ladies and gentlemen. Today we're looking at my favourite tool in the world called Financial Solver. A lot like Regular Solver, how Regular Solver just nails equations, this nails financial problems, providing you know how to use it. And a lot of problems can be solved here, but you can also make some very easy errors which result in terribly wrong answers. You can also make easy errors which result in wrong answers that look like correct answers, which is even worse. So, Financial Solver on the calculator in main run mode is just menu 8.1. It looks like this. Menu 8.1. Lovely. Now, importantly, you're going to have to fill in almost all of these, so you'll need to know what each of them mean. N is the number of compounding periods in total. So, for example, if the loan was for 25 years compounding monthly, well, that's the number of compounding periods is 25 lots of 12. You would put the number 300 in there. I is the interest rate as a percentage. You don't have to convert it to a decimal. PV is the present value, or the initial amount of the loan or investment. Payment is the amount paid each period. So the investment might be shares that pay out a dividend each period. It might be a loan where you're paying in each period. Future value might be is the amount left at the end of the term. It might be 0 because the loan has been paid off, or it might be a much larger number if you're making an investment. PPY is payments per year. CPY is compounding periods per year. For further, these are always the same. So for example, if it was compounding monthly, the arrow wasn't meant to come. If it was compounding monthly, you would assume they're paying monthly, and you would just put the number 12 in there. I'll look at this in an example in a sec. It is possible that, for example, your mortgage might compound monthly, so charge interest every month, but you might be making payments every fortnight simply because you get your paycheck every fortnight and you make the payment straight away. That would be quite a normal thing, and that's how you could use Solver to adjust for that. But in further maths, those two are always the same. Same, pay at the end. We assume that the payment is made at the end of each month rather than at the start, and a VCE, that's always the case. So the last three are fairly easy. Where 99, 95 maybe, % of students get it wrong is these three. And that's because they need to be very careful of the signs. And by signs, I mean plus or minus. Plus. Plus is a good thing for you. A good thing for you is money coming to you. Alright, so for example, if I invested money in shares, every month, say I invested 10,000 in shares. Every month they pay me $1,000, and at the end I get $1,200 back, for example. Initially, I invested $100,000. That is money going away from me. I would be putting in present value of minus 100,000. I'll use a pen. Every month, we decided they paid me $1,000. That's positive. Payments would be $1,000. At the end of the term, I get another $1,200. So if money is coming to you or to the person in the question, it's assumed to be positive. And this will only work if the signs are right. Now, note, if it's negative, the money is going away from the person in question, or typically it's to the bank, but it can also be into an investment, into a hole in the ground, etc. Negative is money going away. So, another example would be, let's say I borrow $300,000, paid off in monthly repayments of $250, $2,500, and at the end of the period, I have no more mortgage to pay off. The present value is positive $300,000. The reason is because when I took out a loan of $300,000, I effectively received $300,000. Yes, I didn't get a big suitcase, it went away in a house. But it was positive in the initial case because money was coming to me. Each month, this happens, etc. And at the end, there's none left. The values we put in to these three cells are incredibly important and really very difficult. Alright, one example. One quite long involved example. We have a couple who buy a house for $550,000 and pay a $60,000 deposit and borrow the remainder at 4.5% compounding quarterly. Highlight the quarterly. Note that they're also going to pay off quarterly. And this is to be amortized, meaning amortized to be paid off, over 25 years. What are their quarterly repayments? You may have noticed up until now, the quarterly repayments have been given to you. We've always just said, oh, it's this amount. The reason is we can't work out what they are unless we use Solver. There's no recursive tool we could get it with. N is, well, quarterly for 25 years. There'll be 100 in there. I is always just 4.5. Don't convert it to a decimal. Present value is the amount that they borrowed. So it's a starting amount. In this case, it wouldn't be $550,000 because that was the cost of their house. However, they paid a $60,000 deposit. So they subtract the $60,000 away, and all they need to pay is $490,000. The payment, we don't know. If we don't know it, we're going to leave it as a 0 in our calculator. Future value, we want the future value of the loan to be nothing. If you borrow $490,000, eventually you don't want to owe that amount, you want it to drop to 0. PPY is payments per year. 4, CPY compounds per year. 4, they're always the same. And it's 4 because it's come from quarters. Alright, now note the working. The working out for this problem looks like that. It's not a series of equations or steps. It is just this, and normally we would put a question mark here. In the actual calculator, you will enter it in the calculator. Here, you'll enter question mark in working, and then you'll say in the sentence, the payment amounts are equal to, so on. And we'll write it in a dollar. I'll show you how to do it in the calculator now. But it's important to note that the working required is a screen dump of Solver. So here, what do we say? There was 100 there. Note if you say 4 times 25, that's fine as well. Press tab to go between them. Interest rate was 4.5%. Present value was positive 490,000. Positive because they got the money. Payment amount we don't know, so we'll leave it as 0. Future value is 0 because that's the amount the loan will drop to. Payments per year is 4. Note that it automatically changes CPY to 4. Compounds or payments are at the end. Then what we do is we bring our cursor back up to FV and see how at the bottom it says press enter to calculate. We want to be on payment because we're trying to find payment. Once again, we're pressing payment to calculate. So hit enter. They will need to pay, note the negative sign there, which is good because they're paying out money. They will need to pay $8,187.26 per quarter. That is going to be 8,100, was it 87? 87.26. Note that with dollar values, they won't tell you the number of significant figures or decimals to go to. You must go to 2 decimal places because that makes sense with money. Alright, how much do they still owe after 5 years? Because I'm running short of time, I'm just going to give you the solution, but in your working and your reference book, I expect you to put in what I'm putting in now. Like, write down the screen dump of the working. So here, after 5 years, so we know that that's the payment. Great. After 5 years, we won't have done all 100 compounding periods. 5 years, sorry, my computer's freezing up. 5 years is just 5 lots of 4 compounding periods, or 20. So, we want to work out how much is still owed after 5 years. we leave that payment in there and hit enter on FV, it is 430,000, etc. Note that it's negative because they still owe that amount. So they're still in negative that amount of equity. What was it? 430,382.39. 430,382.39. 392939. Apologies. Dollars. Remember the dollar sign? Once again, you'd have to have working there. All right. How much interest have they paid over the first 5 years of the loan? Now here, interest is a very common question. Jesus Christ. And it's common in that the VCE love asking it. So here, they've made a whole bunch of payments, and the principal's reduced. The difference between the payments and the principal reduction is the interest. Let me explain. They started with a $490,000 loan. And after 5 years, they're still remaining $430,382. That doesn't work. All right, that there is the principal reduction. It's how much the loan has been reduced by. All right, now let's figure out how many repayments, how much they've actually paid into their loan. I apologize, my computer is seizing something chronically. It's really frustrating because these things are new. All right, each quarter, they paid that amount, 8,187.26. And they've done this over 5 years 20 times. So it's 20 times 8,187.26 is this. So what's happened is they've paid $160,000 to the bank, but the loan has only gone down $60,000. This here is the total repayments made. All right. Then we want to work out total interest paid is equal to the principal reduction, the difference between them. So total repayments take principal reduction which is going to be 163,745.2 take 59617.61. The total interest they've paid is 104,000.127.59. You're wondering where banks make their money? It's there. There's where they make their money. All right. Now, there's actually several more parts to this video. I'm going to pause it so it's not a huge file and you don't freak out. It's already a pretty long one. And we'll do round 2 in a second.